Hi everyone, my name is Krista Dietrich, and today I am going to do a presentation on a genetic disorder known as sickle cell anemia. So what is sickle cell anemia? So just a quick summary before I go into too much detail. Basically, it's a mutation in the HBG gene which causes red blood cells to sickle and to change shape. Normally, red blood cells have a nice circular shape to them, but a sickle cell has kind of more of a, I don't know, jagged shape to it, and it leads to a lot of painful abnormalities in patients. It's also an autosomal recessive disorder, so both parents either have to have the disorder or be carriers for it in order for it to be expressed in their offspring. And it's primarily found in African, Hispanic Americans from South America, Middle Eastern, Asia, India, and of Mediterranean descent. And many symptoms from sickle cell anemia include anemia, fatigue, and pain. So, sickle cell disease is a group of disorders that distorts hemoglobin. Sickle cell disease has been known to African descent for hundreds of years, as I've stated before. A doctor of Ernest Irons had a patient who was the first documented case for this disease in 1910. In the 1950s, it began clear that the disease was inherited and would be homozygous for the disease. A person with SS disease will have a hemoglobin molecule called hemoglobin S, which distorts red blood cells in a crescent or sickle shape. This disease has been known for hundreds of years and affects millions of people worldwide. So, the hemoglobin subunit beta gene is responsible for the genetic disorder. The mutation sticks to the red blood cells, which ultimately causes the sickle shape. As I stated earlier in this presentation, the mode of inheritance is autosomal recessive. So both parents must be either homozygous recessive or heterozygous. And here over in this picture or figure, you can see that both parents are at least carriers, and one of their children ends up actually expressing the disorder. Two are unaffected and one is a carrier. So also with the prevalence of sickle cell anemia, it affects millions of people. However, statistics have shown that those who are ancestors are from Africa, the Mediterranean countries, the Arabian Peninsula, India, Central America, and parts of the Caribbean. According to the Nationality Library of Meridian, sickle cell disease is the most common inherited blood disorder in the United States, affecting 70 to 80,000 Americans, which is quite significant. And here's a pedigree showing how the autosomal recessive disorder affects offspring. So here you can see that both parents are carriers, but they do not express it, and they end up having one child that is not affected, one child that is affected and expresses this, and two children that are just carriers for the disorder. So for genetic testing options, mainly, well, now it is a law that all newborns must be genetically tested for sickle cell anemia, and they utilize amniocentesis. They use chorionic villus sampling, also known as CVS. They can also use a blood sample and swab of cells from mouth. So there are multiple ways that you can test for this genetic disorder, and it's typically done in newborns and fetuses as well, but there are some special cases where adults come in and they might be expressing symptoms of the genetic disorder, and they'll do just a quick blood test, and It's fairly simple to find out if you're a carrier or express it or not. And just some quick facts here. Some of the symptoms are anemia, which is a shortage of red blood cells. There are a lot of episodes of pain, also known as pain crises, and this is common because when the red blood cells sickle, it causes them to stack on top of each other, and it can build up, leading to cardiovascular problems, but it can also build up around the joints, which can be very painful for a lot of people. And so this disorder, although you can't see it internally, it's very, very hard to deal with for those patients, and I'm assuming very, very painful. Can lead to frequent infections, yellowing of the eyes, and vision problems. So treatment for this disorder, there really isn't a treatment as of right now, unfortunately, to change that abnormality on the red blood cell, but there is a lot of things that can aid in helping you live your day-to-day life without being stuck in bed because you're in so much pain. So some different things that doctors will do are blood transfusions. There's a stem cell transplant, but that's only for severe cases because it is very invasive. It involves a transplant of bone marrow, which it's extremely invasive and very painful, so that's not as highly used. And then some medication that is commonly prescribed is hydroxyurea to reduce pain, and Adakavea or Oxybrita, which is an FDA-approved treatment for anemia as well. And then here I just included a quick little slide for just some fun facts on sickle cell disease right now. And so on here it says individuals with sickle cell disease are living longer. Many are unable to access quality care. There's also a lack of treatment options to effectively address their condition. So only 1 in 3 children with sickle cell disease receive appropriate monitoring for stroke by age 2, because children and newborns that do have sickle cell disease are likely to have strokes when they're really young. And so if they're not getting the health care that is needed for this disorder, they could end up having a lot of problems down the road. 90% of children with sickle cell disease do not survive to adulthood in resource-poor countries. So think about that. Think about the places that I listed earlier of the prevalence. Africa, Asia, the Mediterranean. I mean, places that aren't necessarily the richest countries. They have to deal with this on a day-to-day basis, and yeah, it's just really amazing to think about. And yeah, those were just a couple fun facts. You can keep reading over that. I'm not going to read that whole poster, but yeah, just some interesting facts on this disease and how it really does affect a lot of people all around the world. And here are my references for this presentation. I hope that going over this, you kind of got a better idea of what sickle cell anemia is, because I always have heard of it, but I never really researched it. So it was actually a lot of fun to go into and see, the molecular cause, the prevalence, the genetic inheritance. I mean, yeah, I just had a lot of fun with this project, and I hope you enjoyed my presentation. If you have any questions or comments, just leave a comment on the discussion post. All right, thanks guys.